The following topics are covered in this module.
Regulations and standards, ISA IEC 62443 series overview, course primary sources, ICS versus IACS, ISA 99 committee, and ISA IEC 62443 series.
After completing this module, you should be able to identify ISA IEC 62443 as the focus of this course. Identify the differences between regulations and standards. Explain the difference between normative and informative. Describe the structure and content of the ISA IEC 62443 series of documents. Summarize the role of ISA 99 in developing documents within the ISA IEC 62443 series.
Section 3, regulations and standards.
Here we have an alphabet soup of cybersecurity regulations. These are a few examples. What regulations are specific to your country and industry?
There are many examples here like ISA, ISO, DOE, NIST, AGA, OSHA, NESA, UAE, DHS, FERC, ICPA Japan, SEC, FISMA.
Here we have some mandatory regulations in North America and Europe. Chemical Facility Anti-Terrorism Standards from the U.S. Department of Homeland Security. The U.S. Nuclear Regulatory Commission's cybersecurity rules. There's the Department of Energy, our Federal Energy Regulatory Commission, FERC. They have mandates for the electric industry. Their NERC-CIP has been adopted by Mexico and Canada. The Network Code on Cybersecurity for European Electricity Grid Operators has established rules on cyber risk assessment, common minimum requirements, cybersecurity certification of products and services, monitoring, reporting, and crisis management. It also provides a clear definition of the roles and responsibilities of the different stakeholders for each activity. EU Network and Information Security NIS Directive, EU 2016-1148, is the first piece of EU-wide cybersecurity legislation. It includes three parts: national capabilities, cross-border collaboration, and national supervision of critical sectors. Think about the ones that you have in your region or industry. What is mandated? So let's think about the limitations of mandatory regulations. A review of publicly available information shows that there's mixed resistance to mandated government frameworks and policies. Different countries approach that differently. Not all frameworks and regulations that exist align well with each other, even within a country. The number of enforced cyber and physical security regulations is growing. Some nation-states may have cybersecurity strategies that are still evolving. Public-private partnerships are lacking in some countries and sectors. Then we have the sector-specific cybersecurity plans that the governments may be putting out. Here in the United States, we actually have 16 different sectors, like chemical, water, electric, and even hospitals and financial banks. Regulation compliance is mandatory, while standards compliance is voluntary. But there is one general agreement across all the nations. No country or government can address cybersecurity risk in isolation. Remember, we talked about the fact that malware has no borders. Standards are voluntary codes for which there are no legal obligations to comply. There are no requirements to use them unless it's agreed to in a contract or referred to in a regulation. In the absence of any type of relevant regulation, if something goes wrong or there's a breach, the courts may look at it and say, "Were you compliant with the standard?" What would a reasonable man on the street do? We call that the MOS test, man on the street. This question is used to determine if there are sufficient grounds for liability. Compliance with the standards is notionally voluntary. However, in the case of litigation, failure to comply with an existing standard or typical business standard process may result in liability if that would have reduced or eliminated the impact of the occurrence. It might be deemed as demonstrating negligence and not taking due diligence. Most standards contain both normative and informative elements. The normative elements are those parts that shall be complied with in order to demonstrate compliance with that standard. Normative elements are indicated by the use of words shall or must. The informative elements provide clarification or additional information like guidelines. The informative elements cannot contain requirements. The words shall and must are not used there. As we get to the 62443 standards, we'll point out the normative and informative elements.
We'll begin with a short description of the committee, its scope and purpose, and how that purpose fits within the larger context of all ISA standards and practices. As with any large effort of this type, there's a lot of moving parts. It's overwhelming to try to understand, and it's easy to lose track of it all.
This graphic, taken from the ISA 99 Committee's webpage, provides an overview of the ISA IEC 62443 series of standards. The development status of each document can be found using the key provided. The primary sources for this course are circled in red. These include the published versions of Part 1-1, Part 2-1, and Part 3-3 of the ANSI ISA version. The graphic indicates revisions are in progress for Parts 1-1, 2-3, 3-1, and 3-3. There's a new revision of Part 2-1 which was approved with comments. It's awaiting publication. Part 3-2 was published for the first time in October 2020. This course will focus on published standards, though we may mention the progress of revisions. You can check the ISA 99 SharePoint site for the latest status. The diagram organizes documents into 4 distinct groups, each with a specific focus. The first, or top group, General, contains standards and reports that are general in nature. The second group, Policies and Procedures, addresses the people and process aspects of an effective security program. The third group, System, focuses on the technology-related aspects of security. The fourth group, Component, focuses on specific security-related technical requirements of products and components. You should be familiar with these 4 groups. Going over the work product highlights, there are 14 publications, of which 10 are standards and 4 are technical reports. Technical reports, or TRs, are informative publications. They provide data or information on a particular technical subject. A TR looks like a standard, but it's informative. It doesn't use any shall or must statements. Standards use shall or must statements. There are nearly 400 of these normative requirements, which turn into standards. Again, these contain the shall and must statement, and approximately 150 requirement enhancements shoring those up. When these are combined, there are over 900 pages. The official designation for the standards is either IEC 62443 or ANSI ISA 62443, depending on which edition is purchased. For convenience, we're recommending the use of the less formal designation ISA IEC 62443 to highlight that both editions are identical in content. Also note that for the ISA editions, the ANSI prefix applies only to standards and not technical reports. In the general group, Part 1-1 introduces the terminology, concepts, and models used throughout the series. The intended audience includes anyone wishing to become familiar with the fundamental concepts that form the basis for the series. There's a master glossary of terms and definitions that are used throughout the series in Part 1-2. The master glossary, which is a work in progress, will likely be delivered in an online format. Part 1-3 describes a methodology to develop and quantify metrics that are derived from the process and technical requirements in the series. Part 1-4, IACS Security Lifecycle and Use Cases, provides a more detailed description of the underlying lifecycle for IACS security, as well as several use cases that illustrate various applications. In the Policies and Procedures group, we start off with Part 2-1, Establishing an IACS Security Program. It describes what's required to define and implement an effective IACS security program. In Part 2-2, Security Program Ratings, there's a methodology provided for evaluating the level of production provided by an operational IACS against the requirements in the ISA IEC 62443 series of standards. Part 2-3 is a popular technical report on patch management processes in the IACS environment. The industry has been seeking the holy grail of patch management, and this technical report lays the foundation for the process. Part 2-4 specifies requirements for IACS service providers, such as system integrators or maintenance providers. Part 2-5, implementation guidance for IACS asset owners, provides guidance on what is required to operate an effective IACS security program. The intended audience includes asset owners who have responsibility for the operation of such a program. The system group starts off with Part 3-1, Security Technologies for IACS, which describes the application of various security technologies to an IACS environment. Part 3-2, Security Risk Assessment for System Design, addresses cybersecurity risk assessment and system design. The output of this standard is the zone and conduit model, the associated risk assessments, and target security levels. These are documented in the cybersecurity requirement specifications. Part 3-3, System Security Requirements and Security Levels, describes the requirements for an IACS system based on security level. The principal audience includes control system suppliers, system integrators, and asset owners. The last group is Component, which includes two parts. Part 4-1, Secure Product Development Lifecycle Requirements, describes the requirements for product developers' security lifecycle. The principal audience includes the suppliers of control systems and components products. Part 4-2, Technical Security Requirements for IACS Components, describes the requirements for IACS components based on security level. Components include embedded devices, host devices, network devices, and software applications. The principal audience includes suppliers of component products that are used in control systems. Planned future work on Part 1-5 specifies a scheme for cybersecurity profiles. Profiles based on this scheme are intended to be published as subparts of the 62443-5 series. Interested parties can use profiles to adopt a defined set of requirements specified in the series. For example, a substation profile will be a set of requirements describing the substation as an object that has specified 62443 attributes. This is a work in progress. Part 1-6, Applying 62443 to IIoT, Industrial Internet of Things, is primarily for the asset owner, but may interest the service providers and product suppliers. Part 6-1, Security Evaluation Methodology for ISA IEC 62443, Part 2-4 will specify the evaluation methodologies to achieve repeatable and reproducible evaluation results for the Part 2-4 requirements. Part 6-2, Security Evaluation Methodology for ISA IEC 62443, Part 4-2, will specify the evaluation methodologies to achieve repeatable and reproducible evaluation results for the 4-2 requirements. As you can see, there's a lot of work going on by the ISA 99 committee. It is quite an accomplishment for a committee supported by over 1,000 volunteers across the globe. In this course, we use the ANSI ISA format and focus on the 3 standards circled in red. Copies of these 3 standards are provided as part of your course materials. These include 62443-1-1, Concepts and Models, often referred to as Part 1-1, 62443-2-1, Security Program Requirements for IACS Asset Owners, often referred to as Part 2-1, 62443-3-3, Security System Requirements and Security Levels, referred to as Part 3-3. You may be wondering, is it ICS or IACS? ICS stands for Industrial Control Systems. It is a general term for types of control systems acting together to achieve an industrial objective. IACS is an acronym for Industrial Automation and Control Systems. You may hear it referred to as the letters IACS or pronounced as IACS. The 62443 publications use IACS and takes the definition a step further. It's a collection of personnel, hardware, software, and policies involved in the operation of the industrial process that can affect or influence its safe, secure, and reliable operation. The International Society of Automation's Committee on Security for Industrial Automation and Control Systems is known as the ISA 99 Committee. It was established in 2002 with just a handful of members and has grown exponentially to over 1,000 volunteer members, representing all automation industry sectors. It's not specific to any sector or industry type. Membership is global, which is very important, as it is consistent with ISA's global reach and mission. Being global makes it a challenge to reach a consensus sometimes. However, it is moving along and progressing. A group using consensus is committed to finding solutions that everyone actively supports or at least can live with. The ISA 99 Committee establishes standards, recommended practices, technical reports, and related information that defines procedures for implementing electronically secure manufacturing and control systems and security practices and assessing electronic security performance. Guidance is directed toward those responsible for designing, implementing, or managing manufacturing and control systems, and shall also apply to users, system integrators, security practitioners, and control systems manufacturers and vendors. The committee's scope is based primarily on an analysis of potential consequences, as shown here. The committee focuses on improving the confidentiality, integrity, and availability of components or systems used for manufacturing or control, and providing criteria for procuring and implementing secure control systems. Compliance with the committee's guidance will improve manufacturing and control systems' electronic security and will help identify vulnerabilities and address them, thereby reducing the risk of compromising confidential information or causing manufacturing control systems degradation or failure. In addition to ISA, there are two other standards development organizations, or SDOs, interested in developing cybersecurity standards for industrial automation control systems or operation technology. The first of these is the International Electrotechnical Commission, IEC. There's an agreement between ISA and IEC to coordinate on the development of cybersecurity standards. That way, there wouldn't be a duplicate committee in each organization. It's a collaborative approach to working together. ISA 99 takes the bulk of the load, developing most of the standards. There are a couple of standards that IEC has either developed or has promoted, and ISA has adopted them, but it's inherently beneficial to have IEC-ISA collaborate and align. ISA and IEC want to have standards consistent with general cybersecurity standards. If you're in the IT world, information technology cybersecurity, or information security, the ISO 27000 series has been specifically reserved for information security matters. ISO is the adopted acronym for the International Organization for Standardization. The committees want to be consistent. There's a review process to make sure that this all comes together. That takes a little time, but it's good to have input from each committee. The SDOs, Standards Development Organizations, IEC and ISO, have committees that maintain liaison relationships with several other committees and groups within ISA and externally. They work closely with the other committees to ensure that their perspective and needs are adequately addressed. The ISA 99 committee works with ISA 84 process safety and ISA 100 wireless communications. ISA 84 has taken on more importance in the cybersecurity realm concerning the type of assessments you must do for your process hazard analysis, PHA. Collaboration also occurs with Automation Federation, Industrial Security Compliance Institute, ISCI, and the ISA Secure Certification Programs to maintain alignment with the standards. The terminology may differ a bit among the various organizations, but the alignment is the same. We also maintain relationships with external groups, such as the United States Department of Homeland Security. They have an Industrial Control System Joint Working Group and various sector-specific groups and government initiatives in this framework. Now, these aren't just US-centric. There are global players from all the different companies. This is important because many companies such as Emerson, Honeywell, or M&M Mars are global. They need to be involved in an organization that will look at their global perspective and respects that. The ISA 99 maintains active relationships with the IEC and ISO to ensure global adoption and consistency. Perhaps you've been involved in a standard drafting organization or standard drafting team. They all pretty much follow a similar format. There are active work groups. ISA 99 isn't any different. Here's a list of some of the work groups that exist right now. Let's highlight a few of those. Work Group 7, Safety and Security, is a joint work group with the ISA 84 committee. So they're talking about how they can impact each other. Then we have Work Group 9, IoT, Internet of Things. And there's also IIoT, the Industrial Internet of Things. They review the implications involved here. If you want to find out more information, you can visit the ISA 99 site and check the status of the work groups. You don't have to be a member of ISA to be a member of the committee. You can participate by being in a work group or task group. You can contribute to the work activity by reviewing and offering comments or feedback. Various perspectives offer valuable feedback. You can also assist the committee in establishing joint working relationships with other committees and organizations. The ISA 99 committee has 3 membership types. Informational is the default classification. You get to participate in one or more task groups if you want to. You can comment on draft documents, but you can't vote. There's the membership type of voting. Maximum 1 per company based on contributions and nominations approved by existing voting members. You're expected to vote on draft documents. You must participate. It's an active sport. It's not a spectator sport. There's an alternate type of membership where the member is paired with a voting member and given the ability to vote if the primary voting member is unavailable, so it's a backup position. Again, membership types are informational, voting, and alternate. The purpose of these various committees is to support the standards. These committees want to develop a consensus industry standard on automation. ISA 99 focuses on cybersecurity and physical security in the industrial and automation control system space. It takes several years to create a standard. This includes development, the review, the votes, the publications. They're always looking for new participants, fresh subject matter experts. It's all volunteer work. That's typical, again, of any standards drafting organization. It's all volunteer time and effort. You can use it as continuing education units, CEUs, or continuing professional education, CPEs, or as time to support your certifications. You need to check with your certification body to see if this is applicable. You can join the Standards Committee by clicking the link to the ISA Committee webpage. Fill out the form and select ISA 99 from the drop-down menu to get on the mailing list. You'll have access to the SharePoint site in the areas that you're involved in. You do not have to be an ISA member.